Welcome back. In this video, we will be discussing data science for beginners. So before we go into many data science concepts, we need to know some of the fundamentals. Let's see data science. Data science is an interdisciplinary field. Even we can say it's a multidisciplinary field which utilizes scientific methods, process, algorithm, systems, programming knowledge, domain knowledge. The main objective is to extract knowledge. We have a data set, we have a huge amount of data. We need to get the knowledge, insight from both structured and unstructured data. What is the structured and unstructured data? We will discuss that in a later part of the slides. And also, when you talk about data science, it's all about combining the techniques from statistics, mathematics, computer science. We need to have programming knowledge, of course, then domain knowledge. When you talk about domain knowledge, we can say that a healthcare or maybe a finance or maybe a tax related knowledge that will help you to build your entire application. So that's the reason we need to have all the different skills, even a communication skill, which help you to tell a great story to convince your different stakeholders. And also is involved analyzing and interpreting your collected data using a variety of methods and also tools we will be using in our entire module to get to know about all the different programming skills and also data science skills. What do data scientists do? They need to identify insight. So you need to get some kind of insight and also to get the data. That's the more important thing. Then communicate them effectively to the business leader or your stakeholders. You need ideal data sets, determine the data you can access, obtain the data, clean the data. This is one of the important part where you will be spending almost 50 to 60% of your time as a data scientist. Perform some exploratory data analysis, conduct some statistical prediction and modeling, challenge your results where you convey the information to the stakeholders. Lastly, distribute the results to others. You can see suddenly there is a huge demand for data scientists, or maybe you can see there is a huge amount of data has been generated because of all this digital data in the modern era. We can see that with this area, like some of the countries, they have a lack of manpower. So you can see that using a drone image, we can able to capture the cow and capture the other related farming industry data and also many other form of digital data that is are extracted nowadays. With this, we need to apply some insight and also to get some knowledge about it. That's the reason that data scientists are in a huge demand, and also many jobs related to data science are there in a market. So let's move on to the next. So importance in various industries. So data science plays a very crucial role, as I just said, because of the digital data. Previously, we don't have this much of digital data. Now we get lots of digital data. Think of finance, where we can apply data science in fraud detection, risk assessment, and investment analysis. We can use that to predict the future trend in a financial statement. And also healthcare. We can see from the COVID, every government and also every healthcare industry collected lots of huge patient data and also disease prediction, and also it's help for a new drug discovery. Marketing, okay, that's the most important area nowadays where you can see the digital marketing plays the significant role. Customer segmentation, personalized advertisement, where we can have a behavior analytics and also market trend analysis. Transportation, so looking for the route planning. I have a more video, we can watch that video later where you will get some idea on how we can have a digital data that can be collected. Traffic management, predictive maintenance, and also you can see smart city planning. All these places we collect lots of huge data, and also you can look at it. Smart parking, e-commerce, where we can understand the customer demand and also recommendation, product recommendation. IKEA is the best example. You want to go and buy any product in IKEA, you can see the recommended product related to the specific product that you want to buy. It's very unique, where you will get a good reference recommendation for it, and also inventory management. Let's move on to the next one. Before we go into data science, we need to have some fundamental knowledge. As I said before, it's a scientific method, process, algorithm, system to extract some knowledge. Why we are doing? We have a data. If we just keep the data with you, it's not going to be any beneficial. So you are going to extract some knowledge and also from structured and unstructured data. When you talk about structured data, it's a simple Excel sheet where you have all your bank statement very clearly indicated every rows and columns. That goes towards structured data. When you talk about unstructured data, your WhatsApp messages, okay, that goes to unstructured data. And also you can see of your e-commerce product review. All this data can be analyzed and extract meaningful information. So when you talk about data science, you need to have some fundamental concept before we dive into it. So data types, as you are aware of it, you need to be know some of the data types format, so which can be help us to classify our different types of data, so that we can know which kind of algorithm to be selected for this. These types include numerical data, categorical data, and ordinal data, and also which is important for data analysis and modeling. Variable. When we talk about variable, which is a characteristics or properties that can change or vary. It's in a data science, variables can be an independent variable or dependent variable, which are the variables that help us to make a decision, and also it can help us to provide some relationship and also to help us to make a prediction. Lastly, statistical measures. Of course, we start with the simple one, which is a mean, median, standard deviation, summarize and describe the data, and also it can provide a more advanced like a central tendency distribution, shape of a data distribution. That's all goes towards some fundamental. If you don't have knowledge on data types, you please refer to some other resources and get to know about some of the data types. Let's move on to data science life cycle. So when you talk about data science life cycle, it's all transforming a raw data into actionable insight. As you watched in the previous video, where you can able to collect some digital data, from that data you need to provide some actionable insight. To start with it, business understanding. What's your business currently having a difficulty or challenge, or you want to improve certain process or operation? You have to look at that first. Then you have to see what kind of data you can collect related to that specific operation. Then of course you need to do a lots of data cleaning. So this is the place most of the data scientists spend their time. And exploratory data analysis, we have one of the slides in upcoming, so where you will understand that. Statistical analysis, data modeling, where you'll apply your machine learning model, where you have this SPM, decision tree, Ken, and all this algorithm. Data visualization, which is one of the important area, I will say, where you can able to explore and visualize how your data looks like. Even before you go into cleaning, even before you go into applying the model, you need to visualize and see how your data is, how the data are distributed, what are the parameters are there. Of course, after you done all these things, you have to go for a model evaluation, where you use recall, precision, F1 score, and other evaluation metrics to evaluate. And lastly, deploy and iterate your process. So you can see such a continuous process. You don't just go and jump in model applying. When you say data science, people think it's all about machine learning. It's not only about machine learning. It's all about understanding the business first. That's a core thing. What you want to solve. Then what kind of data you have. Or then you have to think of a cleaning. Then you do exploratory analysis. Then you apply some statistical analysis to find out the range of it. Apply some normalization. All this kind of thing. Machine learning, visualization, model evaluation, deploy with the Streamlit. Then it's an iterative process. You keep continuing on your task until your model become more mature. Okay, let's see some on data collection and data cleaning. As I said before, when you want to solve any problem, once you identify the problem, you need to think of your data source. What is your data source in your company? So if you are doing a research, you can just go to Kaggle and you can refer to it. But when it comes to real use case problem from your company, what kind of problem you want to solve, what kind of data that you have, or maybe you can do some survey to collect data from it, or you can use some APIs, like if you are analyzing a data from YouTube, or if you are analyzing any API data. So you can refer to lots of API and databases within your company, and also you can lastly go for a web scraping. Once you collect this data, think of it on the data quality. That's very important. Validating and verifying the accuracy, completeness, consistency of your collected data. Even you can look at bias of the data. Data cleaning, where you have a good understanding on it, where you remove the duplicates, handle the missing values. So you will have lots of duplicates, missing values. standardize the data formats, identify and handle any outlier anomalies, and also transform data where you apply a normalization score min-max method to normalize your data into specific format. So let's move on. Exploratory data analysis. As I said, as you can see here, simple visualization you can do to gain some insight and identify a data pattern. So you will understand the better how your data is distributed. And also further, this visualization help for the distribution relationship and also look at the trend within your specific data sets. So that's how you can start with your data science project. So the moment you understand the problem, then you got your data, then start to do some exploratory analysis to find out what kind of data is all about. So what kind of problem that I can solve with this data set. As I said, statistical analysis is also important where you can do some hypothetical testing, where you use some inference about population or based on the sample data, formulating a null hypothesis or alternative hypothesis, collecting, analyzing a data, making a decision based on the results. Common hypothesis tests includes t-test, chi-square, and also ANOVA. Let's go into some on the regression. This is also commonly used where you start with a linear regression. When we talk about regression analysis, is the statistical model used for relation between a dependent variable and one or more independent variable. We will discuss as we go deeper into regression topic about dependent and independent variable. It can predict the value of dependent variable based on the values in a independent variable. So most commonly used for linear regression, logistic multiple regression. So that goes to some fundamental knowledge on statistical analysis. Machine learning. So as we move on to it, the machine learning is a subfield of AI, artificial intelligence, that's focused on the development of algorithm. Once you've done exploratory, cleaning the data, normalization, all these things, the next goal is to apply some machine learning model where you train your machine. Okay, the data will be used for the model to learn from it and then make a prediction or decision based on the given data for the upcoming data, that the new data that's given. So when you talk about machine learning, the most commonly used for supervised and unsupervised learning. Of course, we have other approach as well. Let's, as a fundamental, you need to have a knowledge about supervised learning and unsupervised learning. When you talk about supervised learning, it's all labeled data where clearly specify whether these are the patient that have a COVID or this are patient have the COVID or not. So clearly labeled, or maybe this person have a cancer symptoms or not. So that's clearly labeled. Algorithm receive a input along with the corresponding output. The process focus on mapping input to correct output labels and also develop a model for accurate prediction. This goes towards supervised learning. If your data is a labeled data, you can go towards selecting the model from a supervised learning. And if you go towards unsupervised learning, which involves unlabeled data, so you have like a unstructured data also you can be used. No output labels are provided to the algorithm. So identify the patterns and structures relationship within the data. So I will recommend to do this first. As soon you get your data, if you don't have a knowledge of what this data is all about, you can apply some of the unstructured, unsupervised learning algorithm to find out. As I said, clustering is one of the commonly used, looking at the similar properties. Example, if you give a population of 1 million data set, as the first thing I will say, group this into four categories, maybe age group, 15 to 20, 25 to 30. So that's how you can start your research. So that will help us to form your group 1 million data. You can form the group so that you should be able to explore your data on this. Data visualization, there are various graphs are there where you can apply this in your data set to find the insight about it and also understand some complex patterns and trends. You can start with the line chart like this, bar chart, pie chart, scatter plot, histogram. We have more than 50 different plots we can make and charts we can draw. And also we can build a very nice dashboard with Power BI and Tableau. So as a fundamental, visualize with any of the simple graph to understand how your data looks like. So these are some of the commonly used data science tools and technology. Of course, it starts with the Python, R programming, and Julia and Scala, depends on the tool that you are using. Big data framework, as data start to grow huge amount, you need to look up for the distributed ecosystem where you can go towards Apache Hadoop, Spark, Flink. If you are building a streaming pipeline where you can go for Apache Kafka. And then data visualization tools, you can start with the Tableau, Power BI, or Matplotlib with Python or Seaborn and other tools. There are more than 50 tools available again for data visualization. Database management like MySQL, Postgres, MongoDB, which is a document-oriented database, which is all will help us. Machine learning and AI platform, or we can call it as the libraries, where you can look at this TensorFlow, PyTorch, Scikit, and Keras. Lastly, as data start to grow, we need to look after some storage part and also other services that provided by this cloud infrastructure like AWS, Azure, Google Cloud, and IBM Clouds. So you can see this video where you can able to count the cars and lorry and bus, which can help us to collect this data, digital data. With this, we can do quite a number of things where you can plan for parking, smart parking, multi-story parking, and also you can plan for your traffic jam. So now this, so you can see these are the different unique data using a YOLO 6, 7, 8, 9. You can build this model within a few hours. Then you can use it for your data collections. Once you collect the data, then you think of it how you can apply this to solve some business problem. Visualization is one of the key components when it comes to data science. You can think of it how you can explore and interact with this data in real time, where you can use these tools like Tableau, Power BI to build your real-time dashboard. So we will look into it, some of this dashboard development as we go into our module. So real world application, I just selected two, which is healthcare, where you can use this predictive analytic to identify the patient at risk developing some chronic disease, where you can use this machine learning to assist in diagnosing medical condition, where you can be more onto data driven insight for personalized treatment and also plan for any precision medicine. So this goes towards applying machine learning or data science in healthcare industry. Looking at the second use case, marketing, where you can see customer segmentation targeted based on demographic or certain behavior. As you can see, many of these e-commerce platforms collect data with the cookies. So whether you reach the landing page or not, which page you stop. So all this thing will be helpful to analyze this data, recommend the system for a personalized product based on your individual user taste, and then you can do some A/B testing, conversion rate, or on optimization for marketing campaign. These are some of the references and resources I use this to build these slides. Thank you. Don't forget to attempt the quiz after you watch this video so that you will have some fundamental knowledge of getting to know what is data science is all about and what kind of process that they do in a data science. Thank you for watching.